Hello students, this lecture will be on sample distribution parameters such as mode, median and mean. So, mode is the most common value that will be in the set of your sample. So if we have an example, it will be like 1, 1, 3, 3, 4, 5 and 6. You see that the most common will be 2 parameters, 1 and 3. So there will be 2 modes in this sample or set. If you go to the median, it's just simple to calculate it if you have odd number of your set values. So you get simple of this. So it's 2 numbers to the left and 2 numbers to the right. If you have even set of values, then you made calculation between middle ones, so it will be in this example 2 and 3. And you just add it up and divide by 2 and you get the value of your median and 2.5 and 2.5 mean. Mean it's in simple. Samples will be just average. See, from mathematics or arithmetics, average number of your samples. So it's very easy to calculate. You just get all your numbers. So you sum, add up your numbers, and then divide by the amount of these numbers or values. So in this sample, you can see here are 5. And the sum of it will be like that 11. And then we divide 11 by 5 and get our mean. This is a simple sample. In next page I'll show you more complex. So you made your survey and you put data of you in table with some grade, age or other values and of course frequency. Then you have to calculate your mean, and in this case I'll show you how to do this. First of all, as in previous, you add up the frequency of your sample. Now it will be 40, and then we have to calculate midpoint. It takes like that. You have the lower boundary of your grade and upper boundary, then divided by 2, as you see in example. So you get midpoints of your intervals. Then you just multiply them, as you see, and get the sum of this multiplication. And after this, you calculate the mean of your whole sample by dividing the frequency multiplying by your midpoints and divided by all the frequency of the sample, as you see in formula below. After calculating the mean or average value of your sample, we must evaluate the diversity of our sample, or its scatter and spread, and by these parameters, the first of it will be range from maximum value to minimum value, as you see in the screen. Then we calculate variance as S square and equal to the difference between the set of our values minus average value, and is all in extent 2. And we divide it by the number of or amount of values in all our sample. Sometimes we have to calculate this in n, and we add here -1, and I'll explain it further later in lecture number 4. Then the conception of variance is very close to conception of dispersion, and its formula you can see on the screen. And then you have to calculate the standard deviation of your sample by this formula. It's dispersion squared or variance squared. And of course, next calculation will be with degrees of freedom, and sometimes go to the student's ratio, so on, and on your sample variance, and will be like your amount or numbers -1. Why variance and standard deviation is so important to your survey? You know, in your survey will be handle your sample only by one value. Usually it's average or mean value, but we don't know how it deal with the whole sample. So by the example I can see, if you measured the height of wilderness of some part, you can see that you hear the trees, maybe trees, 10 meters. Then we have bushes, will be 5 meters, and some grass, half a meter. And when you calculate these parameters, you can hold the average or mean like maybe 5 meters. And then you go to the next population, and you'll have only trees, the same by 10 meters, and only grass. And you have the same average value by 5 meters. You know that 5 meters is characteristic of bushes or young sampling of trees, but you see in the second sample and the second population there is no bush at all. So if we will handle with mean or average further, we can go to nothing in the result, because it's no representation of our whole population. That's why it's very important. So this is the plot of standard Gauss distribution of some random variable or variable of your plot. it indicates that it's very important to evaluate your sample by standard deviation and for further handling and calculation of others, meaning that your data will be variable. Now the lecture is over. Goodbye.